Hey Nano fam, hey YouTube, welcome to the second edition of the RS Nano live stream. And as you can see, it's all much better now, like better camera, better microphone. And we even have the, like here it is, we even have the chat in here. So yeah, I'm super happy with the new setup. And yeah, let's go. So you can say hi in chat, so I know who's here. And today we will talk about Nano maybe. We will have some fun, hopefully. Howdy, hey. Hi, Jan. And this time we will again try to port a simple class from C++ to Rust. That didn't work out the last time. And let's see how far we get this time. And there will be, of course, the Nano giveaway, the 5 Nano giveaway down here. You can see it at 8:30 London time. So for the giveaway, just write your Nano address in chat. And at 8:30, we will just pick by random a lucky winner. Hey, Loris. Hey, nice to see you. Hey, Rui. Hi. So Fiona, that's you, isn't it? Okay. Yeah. So just if you want to take part at the giveaway, just write your Nano address in chat. And if there's any of you who don't know how that works, just simply go to. Let's switch to this screen. Just simply go, open your phone and download the Natrium app. It looks like this, and it's super easy to set up. And once you've got it installed, just click on the receive button and it will show your Nano address, and you can copy it from here, and then you can just paste it in the chat. Okay. Yeah, I remembered that name. So yeah, let's get started. So I guess you all are Nano fans, and we don't have to explain Nano or talk about it. So I guess you all know the project RS Nano, but maybe in the future someone will watch this video. And so just very quickly, RS Nano is a Rust port of the Nano Cryptocurrency, of the Nano node. So this is the project website, rsnano.com. You can find everything about the project on this website. And also, if you want to know about Nano, go to nano.org, and it has lots of information about the Nano currency. So Jan asks, have you considered streaming on Twitch too? And yes and no. So I'm not experienced with streaming at all, so I just wanted to start somewhere, and I thought it's easiest to start on YouTube, but maybe Twitch would be a better platform. So yeah, do you think it would be a better idea to stream on Twitch? Nice Nano hump. Oh yeah. That was a birthday present. I got it from my brother and his wife 2 years ago, because I'm a Nano fan, and they found a company on the internet who printed these humps, and I got it as a present, and I was super happy about it. And maybe we will have a Nano beer in a future stream. So, okay. Yeah, let's get started. First thing that I wanted to show is I have a new coding setup, actually. So in the last stream, I had 2 IDEs, Visual Studio Code for the Rust programming, and it was I love it, and C-Lion for C++. And what always bothered me was the amount of RAM that it took to run 2 IDEs, and yeah, and also like C-Lion was pretty slow, so with code completion and navigation. And then a coworker of mine, he said that he used an extension for Visual Studio Code, the Clang extension. No, wait a second. Yeah, the Clang plugin, and he was super happy with it, and I tried it out, and yeah, now I used that too. So let's switch to the code view. So this is my Visual Studio Code, and now I use Visual Studio Code for everything. So for Rust and for C++, and I can navigate in the same IDE, and it uses only half of the RAM, and it works really, really well, like super, super fast. I can just navigate and code completion. I'm super happy. So this is my new recommended setup. So this is this extension. Where is it? ClangD. So ClangD didn't work out of the box. I had to make some changes to the CMake configuration. It basically has to create a build compile commands file, and it uses that to parse all the source files. But once that was configured, it worked really, really well. So super happy with this extension. And yeah, now I have everything in one IDE. So Jan asks, oh, by the way, shamelessly sharing one of my Nano addresses. Yeah, do that. Oh yeah, so if you have privacy concerns, just create a new address so that people don't know your Nano address. You can do this, by the way, so you can create as many addresses as you like. Oh, I missed some. No, Jan says, I'm following some other devs on Twitch. From what I know, it's better. Also, the chat delays are not that big. Okay. Okay. Yeah, I think I could also stream in... I just picked like normal streaming, but I think there's also like a low delay streaming mode. I haven't tried that out. Okay. Yeah, so what are we going to do today? So in the last stream we wanted to port the backlog population class. This one. And let's go to the header file. And we didn't even start it to port it. Yeah, so this time we will try again. So last time we got lost in callback hell, I would call it, because we just wanted to add a callback so that we could use the class election scheduler. And now everything has changed, because there was a commit in the official Nano code that changed this class a little bit. So before, the backlog population had a direct dependency on the election scheduler. And now it was changed, and now it doesn't have a direct dependency anymore, but it uses a callback, just a generic callback. And that's actually, I think, a good change, because it decouples the system a bit, the classes a bit, and it makes testing easier. So I'm super happy about that change, but it means that everything we did in the last stream is obsolete. So in the last stream we prepared the class so that we could use the class election scheduler, and now we don't even need it. So let's start all over again. And yeah, let's try to port this class, or maybe not even the whole class, because I only want to stream for 2 hours. And yeah, I think this is maybe too much. But if we have a look at the class, so here we have the constructor, the destructor, a start and a stop method. So it starts a thread, and this backlog population runs in the background. So what it does, it just picks accounts by random, I think, and then it triggers the election scheduler for this account. So I think this will help accounts that are stuck to get moving again. And so there's like this thread stuff, and here's the run method, which the thread will run until it is stopped. And the last method down here is the one we will be porting, and it's the activate. So we will port this one because this method here does not call any other methods of this class. So it is, if you imagine it like a tree, it is the leaf, like it is the one which doesn't have any more dependencies, so we can start porting here. So this is the goal for today. We want to bring this method to Rust. And in order to do this, let's see what it does. So it uses this callback. It uses the store. So this is the data store, so where the blocks and everything is in. And it uses the stats class. The stats class is, yeah, what the name says. It's statistics that we can use to debug the node. So we have to have all of this over at the Rust side. So first, so we have to move this to Rust and the store to Rust and stats to Rust. And once we have all of that in Rust, then we can bring this method to Rust too. Okay, makes sense. So if you have any questions, yeah, just ask them in chat. Yeah, so we will just start now with the porting. So once again, maybe this time I thought I would maybe draw a bit so that it's maybe more clear what we're doing. And I have a pen. 1 second. Sorry, I forgot to connect the pen. Let's see, does that work now? Nope. Oh, it doesn't work. Ah, okay, then we won't draw. Maybe just quickly going to the Bluetooth settings. Okay. Does not work, man. Is it connected? Oh, I think it is connected now. Let me try something. Ah, okay. Yeah. Okay. So it works like this. We have the two sides, C++ and Rust, and they both communicate via C functions, and that is called foreign function interface in Rust, or short FFI. So we have in the middle the FFI layer. And now, this is what we want to do now. Whenever we create the backblock population instance in C++, we also want to create a backblock population instance in Rust. And same thing whenever we destroy or delete the backblock population instance. In C++, we also want to delete the instance in Rust. So this will be the first step. This is exactly the same what we did in the last stream. So let's do this quickly. So there's a constructor on the C++ side here. Where is it? Here. And here we have to create or call an FFI function that will create the the backlog population instance on the Rust side. So let's first go to the Rust side. Rust side, so there's the Rust folder, FFI for the foreign functions. And I will put this, I'm going to put this into block processing, and we can move it to a better place if we find a better place. So let's add a file here, backlog population. And let's add this file to the module. Like this. And in this file, we once again, so I copy this now, so then we are faster. Let's just copy this from here. So we will create, we're going to create two functions, like one for creating the instance and one for deleting the instance or destroying the instance. So this is the first one for creation, rsn backlog population create, and it will return a raw pointer. I call these handles, so this would be the backlog population handle. And it contains just an instance of a backlog population. Like this. So down here we say box into raw, which converts the box into a raw pointer. Box new, which does a heap allocation of our backlog population handle, which will contain backlog population instance. And in the second FFI function, we are going to destroy or delete this instance. So rsn backlog population destroy. And this will take this raw pointer and it will just drop, or it will convert it back into a box, and then it will drop it, and this will free the memory again, so we don't have a memory leak. So as you can see now, we have errors here because backlog population, it is not known, it doesn't exist yet. So let's create this struct in, not in FFI, but in Node. So Wenderson says, thank you for your contribution. Oh yeah, thank you. Yeah, it's been a lot a fun journey so far. Kauchuk says, by the way, thank you for recommending C to me on Twitter. It's a lean and easy tech, just like Nano. Yeah, I enjoyed working with Seed very much. I had a look at it yesterday, and I saw that there were no new commits. So I'm worried that it is not developed anymore. So if that is the case, you could also try Y-E-W, so written like this, U. It does basically the same thing, and this is still maintained. Okay, yeah, we wanted to create backlog population in the node module in block processing. So new file, backlog population, and adding the file to the module and using backlog population, and the struct will also be called backlog population. So this struct doesn't exist yet, so let's create it. Just an empty struct for now. Of course, this will be filled soon with all the dependencies that we need. Okay, now we have to import this. Backlog population. Oh, this is still a block arrival, and this has to be a backlog population handle that we return. And there's no new function. So let's create a new function like this. And we don't have errors anymore. So that is good. So the way the project is configured, it should have created the C++ header file automatically now. So let's check. Let's open the file rsnano.hpp. The big God file, like it contains all of the FFI functions, and that is a stupid decision. But yeah, as I said in the last stream, like changing that would, I don't know if it was worth it, because it would be difficult. So let's see if we have the functions in here. They were called rsn backlog population. Here we are. This was automatically generated. So we have the backlog population create and backlog population destroy functions. So now let's use them. Let's go to our backlog population CPP file, or let's first go to the header file and let's add the handle here so that we have a reference to the Rust instance. So rsnano backlog population handle pointer handle. So this is like an opaque pointer, and behind that pointer we have hidden the Rust implementation of backlog population. So of course we have to initialize this handle now. So let's go to the constructor and say handle is rsnano namespace rsn backlog. Oh, there's a comma missing. rsn backlog population create. See how fast the code completion is with this ClangD plugin? I'm so happy with it. So no more waiting. This will increase my progress like a lot. And in the destructor, we call the destroy function, which frees or destroys the Rust instance. And we give it the handle. And oh, this is something that we should always do now, because this handle, we must make sure that we only destroy it once. Otherwise, this would be a memory safety issue. So we should always now delete the copy constructor, so that, because a copy would just copy the handle and then it would be freed twice, and that would lead to a crash. So let's delete the copy constructor. And let's also delete the move constructor. Like, no, what is this? No, oh, I'm not a C++ dev. I always get confused with the... Is this the move constructor? Double? Is it a double ref? Please help me out, chat, please. Yeah, we will see. We will get a compiler error, I guess. Okay. So now we have, whenever we create a backlog population instance in C++, we also create a backlog population instance in Rust. So now let's pass the dependencies that we need. So we said we need the store, we need the stats, and we need the callback. And so this callback will be a bit difficult again, like last time, but I think we can just use the approach that we found in the last stream and just copy it. Kauchik says, sorry, I'm a C noob. Yeah, me too. Okay, so store and stats. So let's move store and stats to the dependency store and stats over. So how can we do that? So luckily store and stats, they are already ported. So if we go to these classes, we should have this one has this method that I added, get handle. It returns like these Rust handles that we've seen so far. So we can use this one. And the same for stats. Stats also should have, yeah, this is just a public field. it also has the handle accessible. So let's add store and stats to Rust. So for this I go to the constructor, and in the create function we should just pass the store handle and the stats handle. And let's go to the FFI, Rust FFI part, and add these parameters here. So what was the first store? Store and then stats. So let's add store handle is a raw pointer to a store. And oh, is there store handle? Why is that not found? What does it return? LMDB store handle. Okay. LMDB store handle. Let's search this LMDB store handle. It is defined in here pubstruct LMDB store handle, defined in FFI source ledger data store LMDB store RS. Do we have to export it somehow? In the mod maybe? Ledger handle? Do we have to export it as store handle? No, was it not ledger? Sorry, that was wrong. I think it should be here. LMDB store handle. Yeah, it was not public. So now we should be able to reference it here. Yes, included. So this is the store handle and stats handle. Stat handle. And these are just handles and they contain the actual instance. So let's have a look at LMDB store handle. LMDB store handle, it has an arc LMDB store. So arc is Rust's version of a shared pointer. So we can just copy this. So let's pass this into the constructor here. So let's say store handle dot oh, let me just check again. Is this public? No, it has a deref for arc. So maybe it would work with arc clone. So we create a new arc, which is short for I think atomic reference counted or atomic reference count. So like this. So nope. Oh, you know what? I'm just I want to do this simpler, so I could just like access the. Wait a second, store. Here, let's just make this pub so I can access it directly. And this needs a reference. And the second parameter would be the stats instance. So here we can do the same. I think stats is also an arc. Yes, arc stats. So let's say arc clone stats handle. That's 0. And so with the arrow we see here, I guess is because we don't have these arguments yet. So let's add them here. So we have a store, which is an arc. Was it an LMDB store? It should be. It shouldn't depend on LMDB. It should be just depending on the trade. LMDB store, and LMDB store should implement the store trait, if I'm right. Yes, so LMDB store implements the store trait. So this is what we will accept, just a store trait and a trait object, and not a direct dependency on LMDB store, because that coupling would be just wrong. Okay, so we will accept an arc for dun store, and we will accept the stats, which is an arc stats. So let's use this. Let's use arc, and looks good so far. So we want to store them in fields. So let's just copy this and like this. And here we return. We just initialize these fields. Store in stats. Yeah, looks good. So now we have these dependencies that we need later when we port that method, except for the callback, and this callback will be the next thing we are going to do. So let's quickly see. We have still some errors here. Let's check this one. So RSN backlog population create says we have too many arguments. Yeah, this, I think the header file was not created yet because we still have errors in the Rust part. So let's fix them first. This operation is unsafe and requires an unsafe function. That is correct, because dereferencing a raw pointer is unsafe. So we have to say that this function is unsafe. And then we have another error here, which says there's expected comma. I think I'm just missing a parenthesis. Maybe again. Okay. Then we have another error here. And that says arc. We have to import arc. And another error here, which says expected a reference to store, but it is an LMDB store. Oh, that's a good question now. How can I clone? There must be a way. How can I clone the arc if I wanted an arc of the trait object? Isn't that possible? Expect reference. Because this expects an arc dun store. This should be possible, shouldn't it? Maybe chat can help me here. Let's see. No new chat messages, and no one has posted his nano address. So, guys, if you want to win 5 nanos, just post your address, and if you're the only one, then you automatically win it. Then we don't have to draw by random numbers. Okay, let's Google how to do this. I'm not sure with the arc. So let's search for arc to arcdun, casting arc to, this is what we want. So how to do this? Okay. Cannot if self is a slice. this be done? Conversion between arc of dyn trade. There's a different article. Oh, it looks like it's not that easy. What a bummer. Do we have to define a conversion function for this? Really? Okay, we can do this. To be. Or we could, just to not get lost again, maybe we could just use for now the LMDB arc, LMDB store arc, and I can find a solution for this after the stream. LMDB store. Yeah, let's. I'm not sure how to solve this now. Maybe there's a simple solution, but I don't want to get lost again like last time. So for now, we just set this to LMDB store, and I'm going to fix it later. So we still have a compiler error. Too many arguments to function call, expected 0. Oh no, the problem went away. So now we are fine again. Everything is okay. No errors, no warnings. Good. So we have the store in Rust. We have the stats in Rust. And the last thing that we need before we can move the function from C++ to Rust is the callbacks. So this is the callback that I think will trigger the election scheduler. And it uses the Nano observer set. So this is this allows for having multiple observers, like multiple callbacks. And let's see if we can simplify this a bit and maybe just have one callback. So let's find all usages of the callback. And we have one in the unit tests and we have one in the node. And it's just one callback. So we could simplify this by just having one callback, and yeah, this will just make our life easier if there's never more than one callback. So yeah, let's do it like this. So I want to encapsulate this public field here for the callbacks by providing a method that okay, Jan says in chat, did anyone post their Nano address successfully? I don't see my messages with it on your screen. Oh, I don't see any. Do you think there's they are blocked? I don't see my messages with it on your screen. So you posted your Nano address and it didn't show up in the chat? Yeah, future of seed seems to be unclear. Top chat. Oh. Yeah, it was my problem. For some reason, like it was selected, top chat was selected instead of live chat, so I didn't get all messages. But now they are here. So there is one. So let's just create a new file here for the giveaway. And I just copy And I copy the name too, so I can say congratulations. So can I post it here? Again, copy, no, copy, paste. So we have one entry. And if is there more? Yeah, there's an, no, this is the same. Okay. Yeah, so Jan, if no one else posts his or hers nano address, then you get the 5 nanos. So where were we? Okay, I wanted to encapsulate the observer set so that we can simplify it and just assign a single callback instead of multiple. So this function, I'm going to call it set activate callback. Jan says, "Oh, come on, guys, post it." So you don't want the nanos? Set activate callback. And set activate callback will take the same arguments. So let's copy them and put them here. Oh no, it has to be a function. A function that returns void and takes these arguments. Kauchuk says, "I'm looking for it." Oh, there's another one. Another nano address. Let's copy that from Wenderson. Copy and paste it into our Windows file. Yeah. Okay. So set activate callback. And this, let's implement it. So basically, as a first step, I'm just going to use the observer set that we already have. So I'm just going to say, let's see how it's called. It's just called activate callback. So let's just say activate callback.add. And oh, there's the name missing for the argument. So let's call this callback A. Let's say add callback A. This underscore A is a convention that is in the nano code. So all arguments have an underscore A suffix. And this is what's wrong here. Use of undeclared identifier activate callback. Yeah, of course. This is a method of the class nano.backlog population. Like this. Okay, so now let's go through the code, and instead of directly accessing this observer set, we just use this function, this method that encapsulated. So where is the references here? So let's go to the unit test. And we have another nano address. Found it. Okay, from Kauchuk. Let's copy it. Let's add it to our file. Here. Okay. Oh, why doesn't it have a space in where the address is? Oh, and I want to save this. You never know. Let's just save it here as giveaway. Next. Okay. Yeah, so this is the unit test, and it should, instead of accessing the activate callback field, it should call the set activate callback function. Like this. And the same for the node. because this is also just one, yeah, just one callback. We say set activate callback like this. So now no one should, let's search again for the usages. Yeah, so now no one is using this field directly, so we can set it private. And now that it's private, now we can actually set this callback in the Rust instance. So let's go to the set activate callback, and here, this is the to-do. This is what's going to be a bit more difficult now. We want to set the callback in Rust. And we're going to do this with an FFI function, of course. So by calling rsn, so this function doesn't exist yet, so let's think about what it should look like. It should be called backlog population set activate callback. And what are the arguments that we need? So of course it needs the handle, so that it knows the instance, the Rust instance that it should set the callback to. And then we have to pass this function to Rust. The problem is we can't pass a std function, but we can pass just a pointer. So let's do this. Let's make a pointer out of this. So let's, again, let's copy this and say callback pointer is a new, so let's say new, that we create a pointer now that contains this callback function. What's the name? Callback A. And now that the callback is a pointer, this we can pass to Rust. But so there's a first problem now. We don't want to create memory leaks. So when we create this pointer with new, we have to make sure that we delete it. So, and it is the responsibility of the Rust part to delete it, because only the Rust part knows when the instance goes out of scope. And so the Rust part has to delete this callback pointer. And for this, we are going to create a function. And let's call this delete activate callback. And it will get a void, so just a raw pointer of the callback. And we have to delete this then. So it is a void pointer because Rust just doesn't understand the C++ functions or C++ names. So we have to return the pointer from Rust to C++ as a void pointer. And here we can cast it from a void pointer to the actual type, back to the actual type. So let's do that with cast. What is the actual type? So we can copy this from down here. It is this a std function pointer. So let's hover and let's close that so we see more. Oh, we could also enable word wrap. Yeah, that's better, isn't it? So callback is now a stood function pointer. And this we can just delete this now. Delete callback. So this delete function, we also have to give this to Rust so that it can call it. So let's do this here. Delete, activate, callback. So we pass the handle, the pointer to the callback function, and the delete callback. I hope this is enough. Let's see. So let's create this rsn. Let's just copy the function name and let's go to the Rust side. And let's create this. So this is the function name. Unsafe extern c fn. And we said we need the handle. And we said that we needed the callback pointer. As a void pointer. And we need it as the delete, the function that deletes the callback pointer. And for this, I've already defined a function pointer type, and this I called it just I think just void cvoid void pointer callback. So let's just quickly go there and so that you can see. So it's just pub type void pointer callback. It's just an unsafe C function that takes a void pointer. And let's add the node mangle here so that we can see it at the C++ side. And cvoid, we have to import cvoid. Okay, so what to do in here now? So the handle has the instance, our block population instance. We can just get it with .0. So here we have access to the block population instance, and here we say set activate callback. But what can we pass in here? So maybe we start by just creating the set activate callback function in the Rust struct. Set activate callback. So this now has to take the callback, but in here we just want to have what we expect. So the actual function signature. So a box fn that takes all the arguments that the C++ part also takes. So let's go back and see what it takes. So it takes a nano transaction reference, an account reference, an account info, and a confirmation height info. Okay, let's do this. So we need a transaction reference. So this would be transaction reference, account reference. What was the next one? An account info reference. And what was the last one? A confirmation height info reference. And all of these types we have ported already, of course. Confirmation height info reference. So what's the problem? It says provide a definition for the function. Oh, I made it. No. Oh, no problem at all. So there was, it was an old error. Import the account. Yeah. We could also define type for this, so it's more clear what this is. Activate callback is this. And activate callback. Callback is an activate callback. And in our fields of the backlog population struct, we can now add this callback as, or activate callback would be an option of activate callback. And we have to initialize it to none, because there won't be a callback in the beginning. Does this still make sense? So chat, if you have any questions or suggestions, please let me know. So let's set this callback. Self.activate callback is some callback. Okay. Oh, I see it's 8:30 already. So in 3 minutes we will do the Nano giveaway. So if any one of you wants to join, just post your Nano address in chat. So yeah, this looks good. So it's just a callback with all the arguments that we have on the C++ side too. So let's go to the FFI part and let's find a way to convert these arguments to the expected arguments. In chat, how do you pronounce this? Guillermo or Guillermo? I'm here. So you wanna post your Nano address and take part at the giveaway? Okay, so we have to add a new a box with the callback function that does the conversion. So what was it? It was the transaction, it was the account, it was the account info, and it was the confirmation height info. Okay, so this now looks good. Now in here we have to do the conversion. And we could do this. Oh, we have a new Nano address in chat. Let's copy it. Give away. Like this. Okay. Guillermo means William. Okay. William. Is it true that you guys have, like, you actually translate names into what? This is Spanish, isn't it? Is it true that you translate names of popular, like of celebrities, into Spanish as well? I've heard that. RSN backlog population. So let's go back to our FFI part. So here we have to do the conversion now. Callback pointer. So there's something missing still, I see, because we have to call the C++ callback, and we have a pointer here to the C++ instance of the callback, but we still need a function that we can call, like a callback function. So let's rename this to context, because this context will just contain, we don't know what it contains, but so we know it contains the std function that we want to call, but we need another function that is that does the call, that executes the callback, which means it will just cast this void pointer back to the std function, and then it will just call it. So this will be, should we give it a name? Yeah. Set. No, just activate. Backlog population activate. Callback is an unsafe extern C function. That will take some arguments. Let's think about it later. So backlog population activate callback, and this we will call now in here. So here we have to pass in. What do we have to pass in? The context. So this is C void. So raw pointer or void pointer. And yeah, let's because this is now getting a bit more complex, let's just do the giveaway quickly, and maybe we have a fresh mind then for finishing this. Okay, so where are the participants? We have four participants. So let's use Google for random numbers. From minimum is 1, maximum is 4. Okay, guys. So when I click generate, the number that appears here will get the 5 nanos. Okay, are you ready? 1, 2, 3, let's click it. So number 1. So congratulations to Jan, you won 5 nanos. So let's copy your address, and let's go to Nano Looker so that I can get the QR code. And where's my mobile phone? My native wallet. Cool, yeah, congratulations. So send, scan QR code. Okay, amount 5. And let's send it. Done. Yeah, you should have it now. Here. There it is. Have fun with the 5 nanos. Okay. So we can close this one. Yeah, it's done, yeah. Nano is so fast. That's the best part of it. So let's go back to the callback. Yeah, so we have to pass a void pointer, which is the context. So let's pass the context. And now we could do this. We say we could pass the context, but this would be too simple actually, because we have to delete the context. So I had this problem before, and I solved it with a context wrapper, like this. Chat delay is huge, says Jan. Yeah, I think it's chat delay is 20 seconds. I think. So let context wrapper. I have this struct already, and I show it. I will show it to you shortly. Oh, isn't it a context wrapper? Context wrapper. Context wrapper. Oh, it's not public. Where is it? It's in cementing. No, we need it. So this is, so as you can see, the context wrapper, it just has the raw pointer and the drop function or the delete function that deletes the context. And what it does is it implements drop, and in drop it just calls the delete function on the C++ side to delete the context. So I want to move this to the utils module, because this is something that I'm going to use more often in the future. So let's go to utils and let's put it there, because now we can use it. It's private context abstract context wrapper. Why is it private? C void, we have to import C void. We have to import the void pointer callback. Kautschuk says, we Nano, it's the most fun. Oh yeah, oh, there was more messages I didn't see. Jan asked, do you guys know about a good faucet I can fund with these 5 Nano? Yeah, we Nano is a good idea. I like we Nano a lot. So, oh, the new function is private. The new and the context function has to be public too, because these are the 2 functions we use. Okay. No more errors in here. Let's close this and let's go back to our FFI part. So context wrapper, we should, yeah, have it now. Here it is. Let's create the context wrapper, and it takes the context and it takes the delete function that deletes the context. And we can now move this into our box. And that means whenever our Rust instance gets destroyed, it will destroy this box, and this will destroy the context wrapper. And this will call the C++ delete function for the callback. A bit complicated, but it works. So, like this. Kautschuk says, I like the geocaching aspect of it. Yeah, me too. So, where are we? We have the context. And now we have to pass these arguments to the C++ side. And we have to convert them into types that C++ can understand, or into types that we can pass via the C functions. So instead of the transaction, we have to pass it as a transaction handle. And this was the big problem of last stream, and we will just copy the solution. And then I'm going to create a helper method for this, but maybe not in the stream because this is boring. So let's go to the place where we added this conversion in the last stream, and that was the election scheduler FFI part, and we have it down here. So I will just use this one, copy and paste. Oh. Kautschuk says, okay, I need to go. Have a good one, Nano fam. Yeah. So thanks for joining, and yeah, have a good one. So yeah, so this was what was giving me trouble last time. And this is like a dirty solution, but this will soon go away, I hope. Guillermo asks, what's your Twitter handle, Gustav? So you should find it up here where... Oh, let's switch to the other screen so I can point to it. Here, there it is. See it? Twitter.com. So it's G. Schauwecker. That's my name, Gustav Schauwecker. And rsnano.com is the website of the project. And here you can see the GitHub link. Okay, so let's fix these errors here. MDB retransaction. So I will explain shortly what this does. No code actions available. Cannot find type LMDB retransaction in the scope. Not found in the scope. Jans in chat says, thank you for the giveaway. Probably send it to vNano or other faucet. I'm still searching for something else. Okay. Or you could just keep it. Consider importing. Yeah, I wanted to import it. Why doesn't it suggest importing it? Use Ars Nano Store LMDB. This is what I wanted to use. Yeah, then let's try entering it by hand. Use Ars Nano Store LMDB. It is up there. Is this a bug? This should work. Oh, it was a bug. Okay. So no more errors here. That's good. So what this code does is it takes our transaction that we have and it does a cast. It casts it into an LMDB retransaction. And this is the dirty part, because we just know that it is an LMDB retransaction, and we shouldn't have this knowledge, but we know it is, and so we just cast it into an LMDB retransaction, and then we throw away all the lifetime information. So we transmute it into a static lifetime LMDB retransaction, which is also very unsafe to do. And this is what we give back to C++. And this works, but don't do this at home, because this is just unsafe and dirty, and it won't stay in there for long. But for now, it works. So this is the transaction handle, and we give that to the C++ callback, and let's add it up here too. So this will be a transaction handle, and now we have to think about who is responsible for freeing the memory, deleting the memory. And we could go two ways. So we could say the implementer of the callback is responsible for deleting it, or we are responsible for deleting it after calling the callback. And that is the way I prefer, because I don't want to remember every time I implement a callback to delete stuff. So if the callback wants to use our arguments here, it should just copy it, and we delete the instances we create. So let's do this. Let's drop it down here after the callback. Let's say drop. What is the transaction handle? It's a raw pointer. Yeah, raw pointer to transaction handle. So let's say box from raw tx and handle. So this will free the memory that we allocated up here. So there's something new in chat. Guillermo says, so I might Rust node as my wallet representative node. Yeah, I operate the principal rep, the Ars Nano rep, but it does not run the Rust version yet. It runs the official C++ version because I want to test the Rust version very much before I switch over. But my plan is to switch my rep to the Rust version this year. So it will be maybe a couple of months until then, but I want to switch it this year. Oh, and there's something I wanted to say. Oh, I've totally forgot. The giveaway we just did, that is from my personal funds. And this has nothing to do with the Nano Foundation. So this is just so they don't get any legal trouble. This is a personal giveaway from my personal funds. And the Nano Foundation does not do giveaways and is not involved in this. Okay. So Jan says, I'm no Rust dev, so to understand this, if you're calling Rust code from CPP codebase, the Rust part must be unsafe Rust. So yeah, there's a lot of unsafe involved, but only in the FFI part. So let's switch back to, let's just move this window here. So the C++ part calls into the Rust part, and it does this by calling the C functions here. This is the FFI part, the C functions, and there's a lot of unsafe stuff going on here, as you can see. So, for example, this function we are working on right now, it has raw pointers to the back block handle. It has raw pointers to the context, and every time we dereference these raw pointers, that is just unsafe. And I don't like using unsafe at all. And there's a lot of unsafe in the FFI part, but the FFI part will be deleted completely. It will go away. Every FFI function will go away in the end, and that will leave us without unsafe parts in the end. Okay. Where were we? So we have converted the transaction into a transaction handle. So now we have to pass the account, and I usually do this just as a byte pointer. So as bytes as pointer. So let's add this up here too. So this is the U8 pointer for the account. And then account info, we have to cast the account info. How can we do this? I think there's account info handle. Let's search for this account info handle. Yeah. There's this account info handle, and let's make this pop. So let's do this here. Box. Oh, same thing. We have to drop it. So let's create it up here. Account info handle is a box into raw, box new, account info handle, and this will contain the account info. Clone. It has to own it. And down here we have to drop it again so that there's no memory leak. Also box from raw. Account info handle. Yep. And now we can pass it here, account info handle. And we have to add the argument into our callback function. Account info handle. And this leaves us with only one last argument, and this is the confirmation height info. And I think confirmation height does not have handles. Yeah. So this uses a DTO. So these are the two strategies that I use. So I either use handles, or I just pass all the values of the class in a DTO. So this is how it's done here. It's just a height and a frontier. So it's very simple. So instead of a handle, we have a DTO here. So, but this is just as easy. So let's create the DTO. And this, we can just convert it, I guess, because I think I've implemented the from trait. So I think we can just say conf height into, and then we can pass it down here, and we have to add it as an argument up here. So this would be that's confirmation height info DTO. There it is. Yeah, no errors. Oh, there's an error. Okay, the conversion doesn't work. Let's go there and let's have a look. Yeah, so because I only implemented from for an owned type, but it is a reference. Do you guys know if there's a simpler way to do this instead of duplicating the code? Because what we need is to convert from a reference to DTO. And this is basically exactly the same code. So do you know if there's an easy way to implement the from trait for references and for references at the same time? Okay, let's go back here. We're done here. I think we're done. Yeah, this looks good. So let's go to the C++ side and finish it over here. Because there should still be errors. Yeah, to do set the callback in Rust. So what do we do? Yeah, so the set activate callback. It where is it? Down here. So this takes handle context callback delete context. Handle context callback delete context. So yeah, so this is what we have to pass here. So handle. So this is the context, the callback pointer. And what was the order? Backlog population activate callback. So let's just copy this. And let's create a function that has the signature. So it's a void function returns void, and the name will be call activate callback. It's not a good name. And this will get a context and transaction handle and an account pointer and account info handle. And yeah, confide DTO. Oh yeah, and this is all in the RS Nano namespace. Okay. So in here the context is our actual std function. So as a pointer. So we can just cast that into our std function, and then we call it. And what are the arguments? So text. Yeah, so we have to give a nano transaction here. So we have the transaction handle here. So let's create a transaction out of the transaction handle. We can do this with nano. This is something we created in the last stream, the transaction wrapper. It just takes the handle. And what is the second argument? Account. So we have to copy the account bytes. We have to copy the account bytes to our local account variable. So next one is account info. So let's create an account info instance. Let's see, do we have a constructor that takes a handle? No, we don't. So let's create a constructor that just takes the handle. Account info handle. Like this. And let's implement this constructor here. Nano account info. And this is super easy to do because it just sets the handle to handle A. Like this. So let's close that. Let's close that. And now we can use this new constructor and just pass in the, how did we call it? Account info handle. And now we can pass the account info to the callback. Oh, we didn't give it a name, yeah. And oh, no, this is not correct actually, because the handle will be deleted if this account info goes out of scope. So we have to clone this so that we don't delete the same handle twice. So we can, I think there's a clone, account info clone, which just takes a handle, and it internally then clones and creates a new handle and returns that. So with this clone, we ensure that when this goes out of scope, it deletes the handle it has, and this handle will be deleted. That we have this handle that we have in here. This will be deleted after the callback on the Rust side, anyways. Okay. Account info. And the last one is confirmation height DTO. So let's create confirmation height info. And Let's check the constructors we have. Yeah, we need a constructor that takes the DTO. Okay, so let's also implement constructor here. What is the name? Just DTO? Yeah. Nano. Ooh, that was wrong register. So, okay. Now we have a constructor that takes the DTO. So let's add the DTO as an argument. Still not correct. No matching constructor. Oh, because this is a pointer. We have to dereference the pointer to the DTO. Okay, this works. And the last argument now is the confirmation height info. And we're done. I think we're done. We are done. So there's one error here, too few arguments. Set the callback in Rust. Oh yeah, so this function we just created, the call, activate callback, we have to, where is it? We have to pass it as an argument. Call, activate, callback. And that's it. So this is, we can delete the to-do comment because we did it. So now we have the callback. Oh, finally, that was tough. So now whenever we add a callback on the C++ side, we have the callback currently on the C++ side, and we have a copy of the same callback on the Rust side. And now we have everything we need to actually port this function that we wanted to port, the activate function. And now we have, in Germany, we have 10 p.m. So should we start this now, or should we do this in the next stream? Are you guys tired? I am. Yeah, I think it will be... Will it be easy? Transaction, count. Yeah, let's do this. I think we can do this in the next 20 minutes. So we have to create an FFI function for this activate. So let's do this. Call this RSN backlog population. Wenderson says you did a lot already. Yeah. Rest a bit. Yeah, but I think we can do this in 15 to 20 minutes, and then we would have reached the goal, or would have reached the thing that I said we would do in the start of the stream. I think I think this part is now really easy. Let's try. If it is not easy, we will stop, okay? Activate. RSN backlog population activate. So this takes the handle and what else does it take? So it just takes a transaction and an account. So let's add it here. Transaction. is a transaction handle, and the account is just a U8 pointer, like this. And down here we would dereference the handle so that we have access to our instance of the backlog population struct, and we would call activate there, and we would pass in the transaction and the account. Oh, I closed it. I didn't want to close it. Activate. So we get a transaction and an account. And down here, we would have to, let's say, to do implement. So let's go back to the FFI. Here's the FFI function and transaction and account. So we can get the transaction easily by dereferencing the transaction handle and calling as TXN. That's a help function that I have written in the past. And account, we can just create an account from a pointer. There's another helper function for this account. Isn't there? Okay, it wasn't imported from pointer. Yeah, account from pointer. Oh. And this must be a reference. So that was it. So that's all we need for on the FFI part. And let's call this FFI function in our C++ part. So I'm just, because it doesn't do anything, I can call it and it won't break anything. So let's call it backlog population. Ooh, why doesn't it show up? I think there's still some errors in here. Or maybe it was, maybe I'm too fast, maybe it hasn't catched up yet. Arsent backlog population activate. And it takes the handle. It takes the transaction handle. And it takes the account as a byte pointer. Like this. So this now calls into the Rust side, and now what we have to do is we have to move this over to the Rust side. So I'm going to copy it and maybe just comment it out here, and let's paste it on the Rust side. And I want to comment it out here too. So debug assert, active callback empty. So I'm going to keep this in, not going to port this one. Let's what we do here. So we access the account store and we get the account. We can do this. Match self.store.account store no.account dot get. Okay. Yeah. Dot get. It takes the transaction and it takes the account. And this will return an option of account. So here, if it doesn't find the account, it just returns. So we can do this. So if it doesn't find the account, we would just return. Otherwise, yeah, otherwise, what does it do otherwise? Oh, we can keep it very close to the C++ version. Let's just return it and let's assign it here, let it count. So then we don't have an option anymore. We have now an account is now an account info. And if we don't find the account, we just return. So here we have this part is done. And what do we have here? The same for confirmation hide store. So this does a lookup in the confirmation hide store and returns, assigns that, or it does assign a default value. So we can do the same. So we can say let conf info is self.store.confirmation hide .get transaction account, and we say unwrap default, which is the same behavior as these two lines. Oh, what does this take? Account. Oh, this is account. This is account. Account info. Okay, so now we have account info and we have confirmation hide info down there. So these two lines are ported too. And let's go down here and comment that if conf info.hide, that's not a function in Rust, is less than account info block count, then we go into here and we call self.stats.inc. Stat type is backlog. Oh, I want to import this so that it's not so long. And detail type is activated. Activated. Also, I want to import detail type. So, like this. And, oh, I need another direction. Direction is, what's the default direction? In. I think the default direction is in. And this returns a result. Yeah. And we don't care about errors here. So let's ignore that. And the last line we need is actually calling the callback. And let's do this here with match self.activate callback. Should we? There's a debug assert here. Should we? Yeah, let's also use the debug assert down here. So if there's no activate callback, I want to debug assert false, so that it crashes. And here we get the callback. The callback is a boxed in fn, and we can now call this with transaction account info and conf info, and we are done. We did it, guys. We just ported the function that we said we are going to port. And of course, so now I have to compile everything, run all the tests, but this just takes forever, and I'm going to do this after the stream, or I'm going to do this tomorrow. But as you can see, we don't have any errors now. We have the FFI part, we have the Rust part, and in the CPP part, we can now delete the commented out code. And yeah, we did it, Jan. We did it. Well, you you did it, yeah. Well, no, it's a journey we do together. Jan says, I'll definitely watch your future streams, and not because of the giveaway. You're doing something so cool, I'm seriously considering speeding up my Rust learning. Oh, that's great. Yeah, so these streams, so I do them firstly because I have fun doing them, and I love Rust, and I love Nano, and I love sharing that. And yeah, so my hope is also to bring people to Rust, to bring people to Nano, and yeah, to show how cool the tech is, actually. Bob says, great job. Thanks, Bob. Oh, Loris, you posted your Nano address, but the giveaway, it's over already. We did it. We did the giveaway 45 minutes ago. Yeah, so I want to stop coding here because we actually did that. So I want to test this tomorrow and push it to the GitHub. And yeah, let's... Wenderson says, thank you for your time and congratulations for your amazing job. Nano is the light. Yeah, Nano, yeah, working on Nano it has been a great journey so far. Lots of fun. And yeah, I have never regretted it. So yeah, if you like this content, just subscribe to the YouTube channel, and from now on, I'm going to stream every Monday, as long as I'm having fun. So this is still an experiment for me, and I don't know how long I'm going to do this, or how I don't know how long I will do this. So my plan is to just look and see. So I'm going to stream every Monday to these times. So 8:30, 7:30 London time, 8:30 German time, and you can see the other times there. And yep, as long as it's fun, I'm going to do this. And yeah, let me know if you like the way the stream is done. So if you have ideas how we could make the stream more fun, or if there's anything that you would like to see, just yeah, write it in the comments or send me a message. Or if you want to help out with RS Nano, or if you like to discuss, you could just join our Discord channel. So for that, go to rsnano.com, and if you scroll down a bit, there is a link to our Discord server here. So just click. Oh, you don't see it. Here. So this is the rsnano.com website. And if you just scroll down a bit, there is a link to the Discord server here. So just click there and join our Discord. And this is the place where we discuss the development or anything related to RS Nano. Yeah, so that's it for today. Yeah, see you next time. See you on Monday. Bye. Guillermo says, already following you. Thank you. Well done. Thanks. So let's end the stream here. Bye.